Coordinate systems are a way of giving information on the location of an object at the surface of the Earth. So they're a means of determining locale. This could be the location of mineral deposits, petroleum deposits, yourself, or any number of things that are located at the surface of the Earth. When we look at coordinate systems, we have several that we will look at. The first is latitude and longitude. And when we look at latitude and longitude, we're going to be making some drawings on the figure to help this make sense. The first thing that we need to start with for any coordinate system is a reference point, or something that we can set to 0 that everything else is based off of. So for us, in latitude, our reference point is the equator, and we set the equator equal to 0. So even though it runs east-west, everything in latitude being measured off of the equator is either north or south of it. And as you can see on the left, or sorry, on the right, the range of latitude is from 0 degrees at the equator up to 90 degrees at the poles. So 90 degrees north, 90 degrees south. Now, the question that you should be asking right now is, why is latitude and longitude given in degrees? Why aren't they given in something that makes sense in terms of a coordinate? So let's say that we want to give the coordinate for latitude to something that's sitting on the surface of the Earth right here. In order to do this, the first thing we need to do is we need to draw a line extending from the location at the surface of the Earth down to the center of the Earth. So let me go ahead and do that. We then need to take and make a line from the surface of the Earth at the equator to the center of the Earth along the plane of the equator, like so. And what we see now is that we have an angle, and the measurement of that angle, let's say it measures 40 degrees, is what our latitude at that location then would be. So the maximum we can have is a 90-degree angle forming at the poles relative to the plane of the equator. For longitude, it's going to be a little bit different. You can see that it's going to be measured east-west. We have the prime meridian set to 0, and it ranges from 0 to 180 degrees. So let me go ahead and draw that for you real quickly. Say this is our prime meridian. It's going to be a solid blue line. Running right here. And for the prime meridian, we set it again equal to 0, but instead of it being 0 on the back side that is dashed, only the front side that we see here is 0. The back side is going to be set to 180 degrees. So you could go 180 degrees from the prime meridian all the way to the back side of the Earth that way, or you could go 180 degrees all the way around the back side of the Earth that way. So even though the line runs north-south, again, your measurements are based off of being west or east of the prime meridian. Same thing, we would draw lines to figure out the angle. Instead of going up and down, they would go in and out, sort of to the left and the right. The other thing of note that you should have for latitude and longitude written down is that lines of latitude are called parallels. And what this means is that every line of latitude runs parallel to the equator. So we can see here there are parallel lines in orange. This means the distance between a degree of latitude anywhere on the planet remains the same. So when we're at the equator, the distance between 1 degree of latitude is about 69 miles. And that stays constant no matter where you are on the planet. It's different for longitude. The way longitude is set up is that we have what are called great circles, meaning every meridian, every line of longitude, has to run through the north and the south pole. So we end up with longitude in a scenario where there is a greater amount of distance between lines of longitude at the equator, and as you move towards the pole, the distance between the lines of longitude gets smaller and smaller. So longitude changes as you move towards the poles to a smaller distance. The last thing that you should have for latitude and longitude is knowledge about how it's broken up. So we have degrees. We have 1 degree, but because that's a little less than 70 miles, say at the equator, we can break degrees up into minutes. Now these are not time intervals, they are distances. So we're looking at 60 minutes distance in latitude longitude. We can further break up each of those minutes into seconds. Again, not a distance, we are looking at, or not a time, we are looking at a distance. So 60 seconds of distance in latitude and longitude. The second coordinate system that I want you to be aware of is the public land survey system. This again is arbitrary. We set it up where we want and how we want. This was developed following the formation of our country, the founding of our country, the United States. And as new land was acquired, we set up the public land survey system during those acquisitions. So we have what's known as a principal meridian running north-south, and you're going to be measuring east or west of it. And then we have a baseline that runs east-west, but again you're measuring north or south of it. Each one of these squares is called a township, and each township has a set of coordinates. So T2S, township 2 south, because you are 2 squares south of the baseline. Range 3 west, because you are 1, 2, 3 squares west of the principal meridian. Each one of these township boxes is then subdivided into 36 sections. The reason for that is each township box is 6 miles on a side. Each one of the sections is 1 mile on a side. So 1 square mile for each of the sections, and you can see the numbers don't just go left to right, they zigzag as we go through the section. Each one of the sections can then be subdivided into quarters most often, but sometimes also halves. So what we're doing is we're taking an area and we're cutting it into smaller and smaller pieces that we can then give the coordinates for. The public land survey system is often used for utility work, surveying, anything that goes along with sort of civil engineering of a city. There are 2 ways of working with the public land survey system. The first is having a map and giving the coordinates 4 points on a map. So let's start with letter A. The first thing that we need to do is we need to figure out, of the boxes that are the same size as letter A, which one is letter A. So that sounds a little bit confusing, but let me help it make a little bit more sense. First thing we're going to do is we're going to put north, east, south, west, because that is going to help us figure out which quadrant is letter A in. So I've highlighted the 4 boxes that are the same size as letter A, and again we want to start from the smallest divisions and work our way out to the bigger. So looking at these 4, we have the northwest, the northeast, the southwest, and the southeast. From this we can see that A is in the southeast, and because there are 4 boxes this side, we call it the southeast quarter of the box that we have highlighted in pink. So we need to write that down. And once we have it written down, we need to move up in size. So southeast quarter for these 4 small ones. Now we're looking for 4 boxes, or, well in this case 4, but sometimes it could be fewer, boxes that are the same size as the one that we've highlighted in pink. So we're looking at this box, that one, and that one. So I'll go ahead and highlight around those. And when we look at these 4 that are now all the same size, we do the same thing. Don't pay attention to this one being divided up. We're looking as A in the northwest, northeast, southwest, or southeast. And again, we see it's in the southeast, and there are 4 of them. So we write down southeast 1/4 again. Because what we've determined so far is that letter A is in the southeast quarter of the southeast quarter of the yellow box we've highlighted. But we're not done yet. What we need next is to find the boxes that are the same size as the one we've highlighted in yellow. So it's this one, that one, and this one. So we highlight around those boxes. And what we see this time, looking at our 4 quadrants, is that A of the 4 big boxes here is in the northwest quarter. So we write that down. And you can see that we have now looked at the section as a whole. So this would be a section, like section 11. So on a map you're typically able to find that information. So I'm going to write down section and township information. That's hypothetical because we don't have it on here. But gives you an idea of what you could see. So what we've determined for the location of letter A is that it is in the southeast quarter of the southeast quarter of the northwest quarter of section 11, township 1 south, range 2 west. We'll do the same thing for letter B. And right away what you'll notice for letter B is that it's not been subdivided as much as letter A. A is taking up a much smaller space, B is in a much larger space. What that means is we're going to have fewer identifiers within the section to determine letter B's location, which then of course is a much larger area. So if we were trying to find something, we'd want it to be something like letter A because we wouldn't have to look in as large of an area. So let's go ahead and highlight the 4 boxes that are the same size, including the one that is with letter B. And when we look at those 4, we can see that B is located in the northeast quarter. So we go ahead and write that down. And then we have to step out and say, okay, let's look at the boxes that are the same size as the one that we highlighted in orange. We have this one, this one, this one, and this one. Again, we see that the one containing letter B is the northeast quarter. And because we have now looked at the trying to write and talk at the same time. Now that we've looked at the section as a whole, because we've done the blocks that incorporate the entire section, we can write the section number, section 11, T1S, R2W. Again, the section number, township range number are hypothetical. You would actually get these off a map when you were working with them. The last one, letter C, let's go ahead and take a look at. And we can see this time, instead of being split into 4 pieces, or 4 boxes like letters A and B were, here we're looking at 2 boxes that are the same size. So we'll go ahead and highlight those 2 boxes that are the same size. And what we need to figure out is, instead of quarters, we're looking at halves. And the way this one is split up, we have an east half and a west half. And we can see that letter C is in the west half. So we go ahead and write that. And again, the next thing we need to do after we write down west half for letter C for these 2 is we need to look at the boxes that are the same size as the one that's highlighted green. So we have this one, this one, this one, and this one. So we can see that of the 4 boxes that are the same size as the one that's highlighted in green, letter C is in the southeast quarter. So we go ahead and write that down. And because, again, we've completed looking at the boxes that make up the section as a whole, we can write the section, township, and range information. So when you're given the position on a map and you have to give the coordinates, you start with the smallest set of boxes and work your way out larger. This is opposite to what you do if you are given the coordinates and you have to subdivide a section on the map to find the location or to plot the location. So when you are given coordinates, you go from right to left, meaning you start breaking up the section, which is the block we have here, based on what is written on the right first. So the first thing we see for letter A is that it is 1/4. So we need to break the section into 4 equal pieces first. So let's go ahead and do that. Draw a line to cut it in half north-south and a line to cut it in half east-west. And again, I'm going to put northeast-southwest on here to help us visualize that. So we've broken up the section into 4 equal pieces because that's the first thing that we see to do in letter A. And the first thing that we see is we are in the northeast quarter. So we're going to be focusing on breaking up this quarter of the section. And how are we going to break it up? That's what the next thing tells us. We again have to break up this quarter now into 4 equal pieces. So we'll go ahead and do that. The northeast quarter will get broken up into 4 equal pieces. And within the northeast quarter, we are looking at the southwest quarter, this one right here. How do we break that up? The next piece tells us we're breaking it up into 4 pieces again. So we need to go to the southwest quarter, break that up into 4 equally sized pieces. And within the southwest quarter, A is located in the northwest quarter. And because that's the last thing written, we don't break up this quarter, we write the letter in it. So A is going to go in the northwest quarter of the southwest quarter of the northeast quarter of the section as a whole. Looking at letter B, we already have some lines drawn up to divide the section, so we'll start based off of that. We have the southwest quarter is the first thing we're told, so we're going to focus on this quarter of the section. We then have to break the southwest quarter into 4 equal pieces, so we will go ahead and we will do that. Within the southwest quarter, we know we are in the northeast quarter, so we're looking at this one. And this time, it has us breaking it into halves. And the question becomes, do I draw a line horizontally or do I have to draw a line vertically? If you're looking at an east or a west half, that means you have to draw a vertical line. It's a very important thing to write down. If you have an east or a west half, you have to draw a vertical line. If you have a north or south half, you would draw a horizontal line. So be sure to make note of that. Here we are looking at the east half, so we have to draw a vertical line to break up what we're looking for. So we'll go ahead and do that. And because this is the last thing that was written for the coordinates of location B, we don't have to break up that east half. All we have to do is write the letter within it. The last one, letter C, tells us first we're in the southeast quarter. So of the section, we are in the southeast quarter here. And we have to break up that southeast quarter into 4 equal pieces. So we go ahead and do that. So we have broken up the southeast quarter into 4 equal pieces. And letter C is the southeast quarter. So since nothing else is written, all we do is we put the letter in that area. So again, when you're given the coordinates and you're breaking up the section on the map, be sure you go from right to left to put those in place. The last coordinate system that we have is the Universal Transverse Mercator system, often referred to as UTM. So when we're looking at UTM, the surface of the Earth has been broken up into zones. Each zone is broken up based on longitude. The way that UTM works is that you are given or trying to calculate coordinates in this part of the world that are meters north or meters east of a reference point. Again, the reference point is set at 0, 0. So we're often given coordinates that look like this for UTM. Now, these are going to make sense in just a second. What we're going to focus on is going through the steps. So say we want to give the UTM coordinates for point A. The first thing that we need to do is we need to figure out what our ruler, and centimeters on our ruler, is in terms of UTM. So the first thing that we want to do, you could either go across east-west or you could measure north-south. We're going to measure east-west for this one. Is you want to measure from one UTM reference point to the adjacent one. So we're going to measure from the coordinates that are 527 to 528, because that's going across this way. So let's go ahead and measure that with the ruler. And what I get for the size that mine is on this printout is 6.9 centimeters. So we're going to make note of that. 6.9 centimeters from 527 to 528. Now, if the image is a different size, this number will be different. This is the size for the image that I have on this printout. So if you're doing this in the packet, your number might be a little bit different because the image is probably a bit smaller. We're going to set this equal to 1,000 meters. So we're going to say 6.9 centimeters equals 1,000 meters. Now, this is not a true statement if both of these were real life, because 6.9 centimeters is not the same thing as 1,000 meters. This, however, works for a map because what we're saying is 6.9 centimeters on the map equals 1,000 meters in real life. So we're converting from map measurements to real life measurements that we would see out on the Earth. Now, why do we set it to 1,000 meters? That has to do with what these coordinates 527 and 528 actually mean. Another way that they could be written is like this. When you have UTM coordinates, they're often shortened, and what you need to do is write 3 zeros behind the numbers that you're given. So make the first little 5 a regular size number, and you see we have 527,000, and that unit is in meters. And then next to it we have 528,000 meters. This is again because we're measuring the meters east of the reference point that we are. So if you subtract these two, take 527,000 out of 528,000, you see the difference between them is 1,000 meters. That's why we set what we measured, the 6.9 centimeters, equal to 1,000 meters, because that's what we're seeing in the map area. Divide both sides of what we've set up for number 2 by the number of centimeters. So I'll go ahead and set that up so we can see what it looks like. I'm going to use a different colored marker to make it nice and visually appealing for you. So we set it up to look like this, so that both sides, the 6.9 centimeters and the 1,000 meters, are divided by the number of centimeters, which is 6.9. So when we go ahead and do the math, this is going to become 1 centimeter equals 140, we'll just call it 5, round it to an even number. So when we divide both sides by 6.9, we find that 1 centimeter with our ruler is 145 meters in UTM. It's also meters in real life, conveniently enough. So the next step, now that we have a way to convert what we measure with our ruler to our UTM coordinates, is that we are going to measure from the lower UTM number, so for us that would be the 527 because that's lower than 528, to the point that we're trying to give coordinates for. So that would be letter A. And then once we get how many centimeters that is, we're going to multiply it by the number we got in 3, which is 145 meters. So first let's measure from the lower number to our point with our ruler. And for the size that my image is, again yours will likely be different because your image is probably a different size, I'm getting 4.9 centimeters. From 527 to letter A. As I'm talking, I forgot what it was, 4.9. And the second thing we have to do, once we get the number of centimeters from the lower number in UTM to A, is we have to multiply it by the answer we got in number 3, which is 145 meters per centimeter. Now we say meters per centimeter because the way it's written here, 145 meters is equal to 1 centimeter, so 145 meters per centimeter. That's going to cancel out the centimeter unit and leave us just with meters. So we'll go ahead and do the multiplication for that. So 145 centimeters times 4.9, or 145 meters per centimeter times 4.9 centimeters is going to give us a number, and again I'm going to round it to an even for simplicity's sake, of 710 meters. So we figured out that point A is 710 meters east or away from the 527 UTM marker. The last thing that we need to do is we need to add the 710 meters that we just got for number 4. Again, your number's probably different because your size of your image is different. And we need to add the answer from number 4 for this video at 710 meters to the UTM marker that we measured from. So here we're going to use the whole number, the 527,000 number. And we're going to add our 710 number that we got from the step above. And when we do that, we find that the coordinate is going to be 527,710 meters east, because again we were measuring to the east. You will do the exact same thing for the north-south. I'm not going to do it in this video, but it's the exact same steps. You measure between two adjacent UTM coordinates with your ruler. You set that equal to 1,000 meters. You divide both sides by the number of centimeters. The great thing when you use UTM is that whatever conversion unit you got, which we got 1 centimeter equals 145 meters, for the east-west measurement is the exact same for the north-south. So really you only need to do this once. So we got 1 centimeter is 145 meters when we're measuring to the east. The same thing holds true when we're measuring to the north. 1 centimeter will still be 145 meters measuring north. So the only thing you really need to do for the north is steps 4 and 5, but instead of measuring it from the east, you'd measure it from the lower UTM coordinate, which in this case is in the south, up to the point, and remember to add 3 zeros at the end of your number for the UTM coordinate so that when you go to add it, you get what it actually is. And instead of having meters east for measuring like we did to the east, this time it would be meters north of the reference point. These are the coordinate systems that we will use in the lab throughout this semester.